Welcome, Kaitaia and Kerikeri. We're here today to demonstrate the importance of the outer electron in the group 1 metals. So these are the group 1 metals. They have, you probably know by now, one loose electron in their outer shell. This group here, I call these too posh to party. These are the group that have got a full electron shell and they don't react with anything. The whole of the rest of the periodic table are unstable the way that they are without a full shell, and so they have to partner with someone else. And we hear all the time about O2, where oxygen partners with another oxygen, N2. And so we'll see what happens with lithium and sodium and potassium that we've got here that are in their natural state. So, goggles on. What I've got here is a tray of just ordinary tap water. I'm just putting some indicator in it, phenolphthalein. That will just go hot pink when the metal, if you recall, these group 1 metals are called alkaline metals, and that's because they will turn the water alkaline, raise the pH. Okay. Now this stuff is under oil because it reacts with water. It will react with air. In Northland especially, it will catch fire if I just left it in my hand. So you can see that it's got a dull coat. That's where it's already reacted with the oxygen, but you can see that the cut surface is shiny, only very briefly though, because it's already reacting with the air. So that's fizzing. It's giving off hydrogen gas. It's making the water more alkaline. And I'm going to pop this bit back in here as well. Now that bit hasn't actually caught fire. Just fizzed away. As we go down the periodic table, so poor old lithium has only got 3 protons, 3 electrons. So the protons and the nucleus are hugging on to those outer electrons, but it can't quite hold that outermost one snugly enough. Sodium has got 11 protons to hang on to 11 electrons, but again it's got that one loose one on the outside. To be stable, it would have to either gain another 7, which is never going to happen, or it's going to have to lose 1. And so lose 1 is what it does. So you can see on the internet it often says that these things don't conduct electricity. I can promise you they do. But it's the coat that's already reacted with the air that doesn't. So if I cut this, you can see shiny because it's a metal. And I'm not going to cut a huge bit off. That's probably actually quite huge enough. So that one's, oh, forgot to put the phenolphthalein in. It's already making the water alkaline. I'm just standing back a bit in case it sparks. Looks safe enough, but I don't trust it. Okay, same deal. That's giving off hydrogen gas. Now, you may have seen either of these in schools. Schools were, I don't know if they still are allowed to have them. They've never been allowed to have this. This is potassium. We have a special license for this. And this is next down in the periodic table, row 4. So that, the outer electron in that is being held by 19 protons, snuggling them in. They can hold on to the inner ones, but they're not able to hold on to the that outer one at all easily. You can see that shiny where I've just cut it, but already it's glazing over. Now this I'm going to be really careful with, hopefully. Put my phenolphthalein in first and move my periodic table. Okay, so you can see that because that electron is further and further away from the nucleus, the protons don't have the ability to hang on to that very outside one, and so it gets quite reactive. Further down that periodic table, rubidium, cesium and francium, we can't even have because we can't contain them. So that's the story of that. Hope you enjoyed it.